Good morning, everybody. How's everybody doing? How many people are online now? There's 12 people online now. Okay, let's see what's going on. How's everybody doing? Oh, look, I got the thing in the way. How's everybody doing today? Hope you had a good weekend. Took Friday off. Okay. Anything exciting going on? Oh, let's change that screen to, I don't want this screen up there. I want this screen up there. Hey, look who's here. Okay, the regular morning people. Anything exciting going on? Okay, people are telling me he's here. Let's take a look. Look at all these people. I'm on. You're usually not here. How many people? There's 17 people on right now. Good, because we're supposed to have like 50. Oh, look at that. Is everybody doing okay? I was thinking Mr. Noah says I should make this more personable, so I was going to show, I told her I was going to show our wedding pictures and stuff online and see how that goes. See if she does that. But what I am going to show is the plan for the week. Okay, so if you're playing along at home, take a look at Schoology. Oh, let me show that here. Okay, take a look at Schoology. Everything's all set for the week, and you will, okay, a couple AP things. I've got so much stuff I want to talk about. You will be getting a survey. You're going to be getting a survey from AP Central this week. And it'll, I don't know what it's going to ask you, but probably, is everything okay? What do you need help with? What can they do? That kind of thing. So be honest with that. Fill it out. Let them know what's going on. For us, okay, you're familiar with this already. E-learning week 3 is where we're at. E-learning week 3 right there. All right, here's the weekly schedule, which you just saw. It's pretty basic. It's just, this is what we're doing. Here's the plan for the week. Okay, the plan for the week. Today we're meeting. We're going to talk about this week's problem set, what subjects we're going to be working on, things like that. So no meeting tomorrow. So you work on the problem sets tomorrow. You don't have to be here. You should still get up early and you should still, but no meeting tomorrow. Work on those problems. Then we'll meet Wednesday, same time, 7:30, and answer questions, see what people have questions on. We'll go over what subjects they're on. And then Thursday you work on it some more. And then Friday, and I have to put this as one of those school requirements, they are due on Friday, okay? Because then, you have like 75 days to turn them in, and they don't count and all that other stuff that, the lesser, whatever. Can't say it. I got to be nice here. So that's the plan. Okay, so what are the assignments now? Okay, take a look. I was able to figure it out. There's 3 problem sets. Okay, we got 3 different problem sets. And like I said, the PDFs aren't the best. I do have the PDFs up here. But they're also on AP Central. Okay, except for problem set 811. I'm working on that. For some reason, that won't assign. But these will assign. Okay, so problem set in the 7.3 and 7.6. All right, those are, okay, logistic. People were asking about a logistic. Those are logistic type problems. Those are differential equation type problems. And we'll finish up from what we were working on last week on those. That's problem 811. Okay, 811. Okay, a couple good AP problems here. They're all about finding the area, finding the volume, finding the cross sections, volume of revolution, finding the area, rotation, all that kind of stuff. That's 811. And 812 is a little harder, not too many there. Okay, but finding the volume rotated around different things, finding the area rotated around different things, the vertical, horizontal, just to review those. Okay, so that's this week. So this week we're going to finish off logistic, exponential growth, that kind of stuff. Remember, I'm thinking that that's going to be a question there. And then here's the finish work on volume and stuff like that. If there's still a subject, I'm just organizing. I have my list of what you sent me a couple weeks ago, and that's what we're going through. We're going through the ones that people have the most questions on. Okay? Okay, so that's the plan. Let me change this here. I didn't. That's the plan. Okay, so this week's the plan is we're working on differential equations. So get that in your binder. Get your binder ready to go there. Differential equations. And then that has, remember, differential equations, exponential growth, logistic, slope fields, all those things, separation of variables, all those things are differential equations. And I'm thinking they're going to definitely put one of those. That might be the short answer one, but they're going to have one of those on there. Yeah. Okay, so how to turn stuff in, because I have to grade stuff. Here's where we're at with grades so far. I put week 1 in there. And remember week 1 where and if I'm missing something, if you miss something, but nothing's for grade, so whatever. Week 2, I first check online. If you did it online, that's you get your A+. If you did not do it online, and like we said under week 2, I had the PDFs. You guys, one class was able to get PDFs, and the other class was. Let me check. Did I have the PDFs? Yeah, so you have the PDF problems here. So if you want to just do those PDFs there, like I said, the PDF format is not the best that AP Central puts out, but that's the best we could do to make it as a PDF. So the PDF problems are there. You could do those and just email them to me. Take a screenshot of them, whatever you want to do. Just checking them in. Just make sure that you're doing them. That's really, I want you to be coming up with me. Remember, I can't say this enough. This is on you. Okay, look right in the eye. This is on you. Okay, your AP test, you're going to take the AP test the second week of May. You have to be prepared for that. And I will try as best I can to try to predict what's going to be on there. Like I said, there's going to be 2 questions, one big question, one regular question, and we'll go over those and we'll talk about those. But this is you have to prepare for it. Okay, so you know what you're stuck on, and that's why you have your binder, you have your calculator. It's all open notes, and so you should try them. You should have your binder open, and as we're reviewing, you should be making notes and making little hints for you in your binder. And then you come across the AP test. When you take the AP test, you go, oh, this is a logistic one. Let me flip quickly, tab right over to my binder right there, because you only have probably 25 minutes to do the problem, and then 5 minutes to upload the problem. That's probably how they're going to do it. And then you'll have another problem. I'm thinking 15 minutes to do that problem and 5 minutes to upload the problem, and that's it. There's your AP test. So you're not going to be able to fumble around and read through your entire notes on logistic. You got to know the stuff. Okay, but a quick little hint to clean it up should be right there. So turning it in, so I'll submit grades because I got to put grades in. I'll put grades last week's grades. It'll just say problem 5.11, problem 6.10, and problem 7.4. And if you did it, A+. If you did not do them, you get no credit for that. And that's just a way to keep track of who's doing stuff. Don't forget don't forget to take attendance online. Make sure you do that. Anybody have any questions? Hey, I mean, there's 20 people here. It should be 50, but 20 people. If anybody has any questions, unsure what's going on, did you take that survey about graduation? I think for those people who were signed up for the SAT in May, I think that's canceled. June still is looking maybe 50-50 in June. And for all those people who are watching, good math going on with this exponential growth and flattening curves and stuff like that. Are you noticing how math is coming into play here? Some good stuff. You should take a look at that. Anybody have any questions? Can we talk about a few problems here, or how do we feel? Let's see. So for 811 is not up there yet. So it's the PDF is up there, but AP Central, for some reason it won't post on AP Central. So I'll work on that today. I'll work on why. Yeah, I honestly I do not know why that one particular assignment. There must be a glitch in the matrix. There's that one particular assignment won't be put on AP. It won't. I can't assign it to you. I could print out the PDF, but I can't assign it to you. So yeah, that's going to be on today. Hopefully, I'll see what I could do with that. So yeah, 8/11. So you could still do the PDF if you want to do them all today and get it done out of the way. Fine, you could do the PDF and then just turn it in. But hopefully I'll get it back. Hopefully it should be working on AP Central. I don't know why it wasn't. All the rest of them posted. I would say, Dina said, is it possible that we're going to take the AP? No. Well, the AP will be this 2 questions. Now, whether we're back in school and taking the AP test in the gym, maybe, or we're on your own and taking the AP test, but it will be this format. It will be online. It will be open notes with calculator and these 2 questions. They've changed that, and that's how it's going to be. Whether we're all taking it together in school or whether we're taking it remotely, if I was betting, probably, I don't know, because we still got a month. Probably, I don't know, 50-50. But it will be this format. So this is what they changed it over. And remember, it's all by state, and AP is a national thing. So if a state says, hey, all our kids are coming back to school, then they'll take it in school. There's been 3 states already, Michigan, a couple other states have already canceled or said school is not coming back in session. And so the people will be out of school. Those kids will be out of school for the rest of the school year. I don't know about summer school. I'm supposed to coordinate summer school, and that's still up in the air too. So Dana's correct. If it AP test normally, this is the test that's going to be administered this year. So whether we do it together or whether we do it remotely, it will be 1 big question and 1 little question. For the PDF, it should post. I'm going to try. That's on the list. I'm going to try to download the answers, and again, the formatting is awful, but I'll try to download the answers. If you take them online, I think I clicked it that says you should see your results, and I'll try to download the PDF answers and see what that see if I can put those up also, sometime at the end of the week. But of course, you could always say, hey, Mr. Noah, how do we do this problem? And we could talk about that problem. Who else? Dana had typed, retracted her message. Anybody else have any thoughts or questions? Hopefully you're doing okay. If you need something, just send me a message if something's going on. That's what let me go to AP Central. That's what, if you need anything that's, you want, I got to enter my password again. Sorry. It locks out. When you start at 5:30 in the morning, things get locked out. Yeah, so Ian said, what about the answers? I'll try to post those, and we'll try to, I believe I could post the answer document up there. All right, so let's just a couple I planned just to talk about. I don't want to take, how's your other classes? Are you guys, how's the workload? Okay, I don't know, just born that way. Actually, Mr. Noah has to go on a diet. After Easter, I stepped on the scale this morning. It said 1 person at a time. So I think it's time for, I got to start working out here. So you can always work on something. That's the key. Don't be stagnant. Don't be not progressing through something. All right. So first reaction. Let's see who says it. We got volume and area. You want to finish working on logistic and series and sequences. I'm sorry, logistic and slope fields and stuff like that. We did that last week. Well, let's try anybody have a preference? Let's try a volume and area one. Go take a look at some of the questions here. We haven't done one of those in a while, so that might be a good review. Come on, it's getting there. It's thinking. Yeah, I don't know why problem set 8.11 would not post. Well, so we're going to work on that. All right, here we go. Here we go. So let's do one from 811. The PDF is up there. Okay, let's do one because there's a couple good free response problems up there. If you want to take a look at the PDF, fine. If you want to just follow along, no problem. Whatever you want to do. Let's go 811. And like I said, if it's not really, okay, the formatting is not the best. Okay, but take a look here. Let's work on this first problem. It's a good free response problem right here. All right, so what do we got? Okay, we got our graph. Okay, we got a graph here. We got our equations. And we want to first step find the area. Let's review that. Let's review how to find the area. Let's go to our document camera right here. And let's see how do we find the area that. Remember, if you're stuck on something, you ask a question. Okay. And so let's see what we got. We got our two equations. We want to find the area. Remember, this is going to be with calculator. Okay, so we have a parabola, okay, from -2. Let's put from -2 to 0. We got that nice little parabola going on right there. It is 1/2 x plus 2 to the second. Right? Is it the second? Yes. And then on the other side, we got a little sign. Okay, we got going here. Let's see where they cross. We'll work on that in a second. We got 2 minus 2 sine square root of x. And this domain is from 0 to pi over 4. Is that pi squared over 4? Yeah, I don't have the PDF in front of me. Pi squared. And this one is just from -2 to 0. Okay, so we want to find the area here. Let's think about how we do this. Okay, first of all, let's check this intersection here at 0. I plug in 0 to that one, and I get 2. I plug in 0 to that one, and I get 2. So that's kind of nice. They cross here at 0, 2. You see that? And let's try down here at -2. I plug in -2, I get 0. So right here, make the dot bigger. This is -2, 0. And over here, when I plug in pi squared over 4, why are they doing pi squared over 4? Look, I got a square root right there. So pi squared over 4, let's take the square root. I got pi over 2. Sine of pi over 2 is 1. So this crosses here at 2, 0. Okay, so we got a nice little enclosed region right there. Everybody see that? And we want to find the area. Like I said, the test is with calculator. This might have been no calculator, but we want to find the area. So let's just do it with calculator since we want to practice the AP test. How do we find the area? Remember, don't forget about, you should have your binder open to area right now. Don't forget about it. We do the practice rectangles. Okay, don't forget about how you learned it and what worked for you. We do the practice rectangle, top over bottom. Okay, I give it motion. Oh, wait a minute. Over here, it's a different top. Okay, so we make another practice rectangle to represent that side. That's how we did it. Okay. Or we could do the practice rectangle horizontal. Okay, but then you're going to have to solve for these. You're going to have to deal with inverse sine. So probably don't want to do it horizontal, but that's still a choice. Okay, everybody see, remembering this? Remember this coming back to you? Practice rectangle verticals. Two different practice rectangles, so I have two different integrals. This integral is from -2 to 0. And then top minus bottom. The bottom 0. That's nice. Top is 1/2 parentheses x plus 2 squared dx minus 0. And then the other one, the purple one, we're going to add the purple one from 0 to 2 of 2 minus 2 sine square root of x minus 0 dx. And we're going to add those two together. Right there. That's, again, just review an area here. That shouldn't be too bad. How do we feel about that? Remember, you got to say something. You can't just be a spectator. Okay, say what you think. If that's okay, that's just area 1. We're doing it's a whole free response problem here. Hopefully you're following along at home. Okay, so now it says, here comes what the stuff we wanted to review is. It says the region is the base of a solid. each cross-section perpendicular to the x-axis are squares. Right, but set up an integral to find the area of the solid. Okay, so now you got to remember, again, how did we do it? Don't forget how we did it. The cross-sections are squares. So the first thing we do is we draw a square out. You see that? That's the cross-section. Okay, so then the integral, keep that picture right there. How does this square intersect that base? Okay, perpendicular to the x-axis. Okay, perpendicular to the x-axis. So if it's perpendicular to the x-axis, notice what's going on. It's red plus purple. So we'll do them separate. Okay. Doesn't the intersect at pi? Did I put 2 up there? Oh, good catch, Beth. Yeah, that should be, I don't know what, it was, no, wait a minute. Oh, this point was, it was not 2. It was pi squared over 4 comma 0. So that should be pi squared over 4. Good catch. Yeah, when you plug in, that's that point right there. Okay, so let's do purple right now for volume. Okay, to do volume, remember, if we're doing purple, here, this is that practice rectangle. That's that little Riemann sum rectangle right there, the one right down there. And I just say this is the integral, and I decide dx or dy. Remember how we did it. Check your notes that you're looking at. This is dx because perpendicular to the x-axis. If it's perpendicular to the y-axis, it's dy. This is perpendicular to the x-axis. This is dx. From 0, and like Beth just said, pi squared over 4. And then it's side squared. It's just the formula, the area of what that cross-section is. Can you see that? It's just the area of the cross-section. So now I go, okay, what is this distance? And as always, that distance is the side. It's the top minus bottom. So this would be the integral from 0 to pi squared over 4 of top function, which was this, 2 minus 2. Don't forget your parentheses. Be generous on the parentheses. Minus bottom, 0. And then that is the formula. I'm squaring it because there's so many parts that you're going to forget. It's not like this is a tough problem, but you're going to forget a lot of stuff right there. You see what I mean? There's just a lot of parts that you're going to be like, oh, wait, I don't remember that. I knew what to do. So have a reason for why you're doing it. Put your bounds. Put your dx or dy. Put your parentheses squared. And then s is just top minus bottom. And then we would do the same thing. Okay, we'd add to that the red. And red, again, from -2 to 0, dx. And then we would do our squared, because the formula is squared. And the top minus bottom again. So top is 1/2 x plus 2 minus 0. Top minus bottom. Remember those? Is that coming back? This is volume. Is that okay? How do we feel there? Just known cross-section. We know what the cross-section is right there. Okay, then, same situation. Let's keep finishing this problem. Then, now it's a rotating one. Okay, this region, it says the region from 1 to 2. Okay, so we're only talking about purple right here. Let me redraw purple then. Hold on here. Here's our graph. Okay, and from 1 to 2, so this function looks like this, but we're only worrying about it from 1 to 2. So just this region. Remember, this is 2 minus 2 sine square root of x. 1 to 2, let's just double check. Pi squared over 4. Where's my calculator here? Let's just make sure. 2, I don't know what off the top of my head. Pi squared divided by 4 is 2.4. So 1 to 2 is right there in that region. Okay? So we want to rotate this region around the x-axis. Okay, rotate this region around the x-axis. Okay, so when we rotate a region, again, no different than what we were just practicing, drawing the cross-section, what's it going to look like? There's only two possibilities. Hole or no hole. Okay, those are the only two possibilities. So I decide, is the rotation going to be a hole or no hole? Now, how do I tell? Is this region always touching the axis of revolution? Okay, remember that. That should be in your notes. If the region is always touching the axis of revolution, then it's no hole. If sometimes it touches or never touches the axis of revolution, for example, what if I rotated this around a line x equals -3? Then it's never touching the axis of revolution. You see, if it's always touching the axis of revolution, let me do it again. What this point right up here, well, 1, I don't know what that point is up there. Let's say this point is A. If it rotated around the line y equals A, well, then it's touching it just at one little corner. So it's still a hole. Only if it's always touching the axis of revolution, it's no hole. Okay, so what do you think about this one? Is this always touching the axis of revolution? From 1 to 2 it is. So there's no hole right here. Okay, so this radius, okay, remember the integral is pi r squared. There's the radius. There's the formula. And I draw the radius. Remember, always put your pen on the axis of revolution and go to the function. That is the same thing as that. And so give it motion. Is that practice rectangle? It's perpendicular to the x-axis. So right away I'm saying dx. And then I go the smallest x and the biggest x. Smallest x, we go, so this is the integral from 1 to 2, pi, parentheses, squared, dx. Remember, that's just our plan. And then it's top minus bottom. Okay, the top function was 2 minus 2 sine square root of x minus bottom, which was 0. Haven't done one of those in a while. How does that look? How do you feel about that? You doing okay there? Just refreshing your memory on volumes revolution? Is that okay? Well, I'm going to pull up another problem here. Let's just do one example on logistic. How about number, let's see, what's a good one? That's a sketching one. I want to find questions that we're supposed to know. Sorry. Well, like I said, the formatting is not that good. Well, I'm waiting for... All right, how about number 3 on 7.3 and 7.9? Let's just refresh our memory on one of those. Number 3, let me put it up here if you can't see. Number 3 is, okay, it said the number of moose in a national park is modeled by the function that satisfied the logistic differential equation. There it is. What is the limit? Now, you should be looking at your binder right now. As soon as you see the word logistic, there are 3 things that should show up in your mind. Okay? 3 things. It should be, first of all, the limit as t approaches infinity of m of t. That should be there. Then also the limit of the slope. The slope is always 0. Okay, and when is it growing the fastest? Okay, it's growing the fastest at half. We call it the carrying capacity. Okay, those 3 things you should be looking at in your binder right now. So all we have to do is, let me copy the equation down here. We just got to take this equation. We got to figure out what the carrying capacity is. So here's a perfect example of, I just copied the equation down. Here's a perfect example of, here's where you just, in your binder, the notes should be right there. So when you say, oh, wait, that's a logistic equation, let me pull up my notes and let me see what to do there. Okay, this isn't the form that we had in our binder. Okay, in our binder, it was dp dt is equal to kp times m minus p. So And notice M was our carrying capacity in our binder. So here's one example of the AP didn't put it in the form that our book put it in, so we got to do a little manipulation here. Okay, how do we do that? Well, notice there's no fraction. So what I have to do is I have to multiply this whole thing. I can't change it, so I'm going to multiply everything by 200 over 200. Okay, now take a look at what that does. dm dt is equal to, if I multiply by 200, I distribute this in, this 200 cancels with this 200. You see that? So that's not changing anything. Everybody see what I'm talking about? We're just getting a common denominator. It's basically, in fact, let me put this 200 over 200 right there, just to show what, get a common denominator. So I got 0.6 times m. Then we got 200 over 200 minus m over 200. And then notice we could do greatest common factor. We could factor out that bottom 200. So whatever 0.6 divided by 200 is, you could see m, I should say the carrying capacity, is 200. Okay, now what does that mean? Carrying capacity being 200, what that's telling you is a couple things. That's telling you the limit, in this case as m of t, as t approaches infinity, is 200. That's called the carrying capacity. It's also telling us that, I don't know what time, we'd have to solve the equation, but I know the m at 100 is when it's growing, the moose population is growing the fastest. You see, the moose population is growing the fastest at 100. When there's 100 mooses? When there's 100, is it mooses? Anybody know that? Growing the fastest right there. And you could solve for t when that is. And that, remember, that's the point of inflection. That's the point of inflection of this graph. So there's a logistic one. They might put one of those on there. Is this, how are we feeling here? Okay. This is just those, that's what this week is about. A lot of area, let's go back to here. A lot of area, volume. This week's about that kind of stuff. And then a couple reviews, slope fields. People were asking about that last week. So we got a couple of those just to finish up our discussion of last week's stuff. Okay? Okay, so there's the plan for the week. Tomorrow, I want you to work on all this stuff. I'll also put in grades today and tomorrow. Okay, because you get 75 days to do your work. I'll put in grades tomorrow. So if I miss something, if I post it online and you're like, wait a minute, I turned that in, then let me know, or just send it again. Okay, because most of the stuff was on AP Central, so I'll just put those in. And plus, a couple people sent me PDFs. That's fine also. So you could turn anything in. There's nothing to turn in until Friday, but work on AP Central, work on your PDFs. That's what I want you to do today and tomorrow. And then on Wednesday, let's get here at 7:30 and excuse me, ask some questions. Let's do a few problems, see what people have questions on, and then this is all due on Friday. Okay, so we'll meet this week, today, Wednesday, and Friday. You got Tuesday, Thursday to work on your stuff, but you can work on it all the time, really. And then remember, get that binder organized. You need to, there's nothing wrong with you saying, hey, Mr. Noah, let's work on this. This part of my binder is not clear, but this is all we're going to be doing until the AP. So we got 4 weeks, and we'll just keep doing this. We'll keep going. All right, here's a section. Here's a type of problem we're going to work on this week, and then we're going to work on it. Okay? Everybody feeling pretty good here? Last problem. Right. What we'd have to do is, and they never ask you to do that, because that takes a good 15 minutes itself to do separation of variables on a logistic equation. So they don't ask you, they'll never ask you to do the separation of variables and do all that kind of stuff on logistics. They might, I've seen it sometimes where they give you the derivative and give you the original function and then ask for t. Yeah, because that's an easy solve. You just have to take the log of both sides and stuff like that. But yeah, they won't ask you to do that. All right, do we feel okay here? Of course, as always, a couple people, you could send me an email. If you're stuck on a problem and you don't want to move on, send me an email and I can help you out and work you through. They give you a little hint and stuff. And then, so let me make some notes for myself that people ask. I will post the answers if I could. I'll try to post PDFs of the answers of these problems online. And then that 811, we got to try to get that one working also. Okay? All right, everybody have a good day. And throughout the day, just send me. I'm always around. But I'll be teaching my kids. Well, they're giving them like adding and counting money. We're doing multiplication and division, but that's beside the point. All right, everybody have a good day. I will see you later.